All right, so I got kicked out, so I'm in a different place. So you can see in the background, my background changed. It's a giant periodic table. I think my diploma is on the wall over here somewhere. Anyways, uh, I didn't get kicked out, but I'm in a different room. So we talk a little bit about the periodic table here, um, and uh, and it's how we lay it out and what we call things. It's sort of give you a little bit of uh, um, a feel for how it's organized. Okay, so there's a blank periodic table here, and then there's a bunch of terms over here, and you're going to have to know most of these. And For metals and nonmetals, you'll kind of have to know what some of their properties are and know where they are in the periodic table. So let me sort of get into this, right? There's groups and periods. Okay, so uh, groups really are columns. Oops. So, for example, there's this group here. And those are the labels for the group. It's either called Group 1 or 1A. The Group 1 is and to 18. This is by IUPAC. And it's the International Union of Pure and Applied Chemistry. And they're kind of like, like the guys that write the rules for the NFL. They just sort of say this is what it is, and occasionally we'll make changes. And if you really don't like it, well, that's just kind of too bad. This is the rules. So they're those guys. But generally speaking, because they're scientists, they take a lot of input, and things get done for sort of a reasonable, uh, in a reasonable fashion, unlike some of the NFL rules and things like that. On the other hand, this bottom row, I was going to call it the OGR, the old guy's rule. It doesn't really have a name, but this is the older system. Okay, and these headings designate the numberings of the groups. So it could be group 1, 2, 3, 4, 5, 6, for example. But if you say it's group 1A, that specifically means right this group here. Now, if you say group 2A, right? Wait a minute. 1B, 2B. Sorry, 1B. This actually means this group here. There's two A's over here. I was just confused about what I really wanted to look for. So actually, what happens is in the older system, we group the elements according to certain types of properties they had, and so we'll get to some of the names. But the B group, okay, the B groups are called the transition metals. The A groups, okay, those are the main group elements. And the reason for that originally was that the A group seemed to go together, and the B group sort of just was in the way in the middle. It's kind of the transition. That's where it gets its name. It's like a transition between the two sides of the A group. Okay, so we have groups. Those are columns. We have the IUPAC system, and we have the older system. I don't even know if it has a name, really. Maybe traditional system, but it's not a really official name as far as I know. And then we have the periods. Okay, and periods. Those are the rows. So if we're talking about columns and rows like you would in a spreadsheet or in a table, that's essentially what the periods are, okay? So the periods run from left to right, and this is period 1, this is period 2, 3, 4, 5, 6, 7, right, like that. And we've pretty much filled out all 7 periods of the periodic table. Some of the elements are natural, and some of them are man-made, okay? And if you want to know how that happens, we'll talk about that in next semester. All right, so what else do we need to go over? Well, there's all these groups, and I like to call them by their old group names because that's what I am. And Group 1 is known as the alkali metals, and 2 is known as the alkaline earths. These are some of the things that you should know for the test. Group 6A you don't have to know, but I put in there in case you go into like the natural resources or geology or geography. This term chalcogens eventually comes up, and they're the elements that form ores. Okay, so like oxygen is one of the main ones that we see. Sulfur, that's in that group. Now halogens and noble gases. Okay, this is 7A and 8A. Halogens and noble gases are those groups. The noble gases get their name because the noble gases don't tend to react with other elements, so they're nobility, and so they just don't hang out with the common elements, right? So that's what that kind of means. All right, so we've covered groups and periods. We've covered all of these. Okay, now there's metals, nonmetals, and semimetals, and we'll talk about properties of metals, nonmetals, and semimetals in a little bit. But how do you know where they are? And it turns out it's not too bad to figure it out. And really, some books will actually continue this line, and I don't tend to continue it. It doesn't make sense to me to do it, and I'll tell you why in a little bit. This is boron here, and this is aluminum. Okay, so aluminum is definitely a metal, but every other, this is a metal. So let me do this. I'm going to get a different colored pen. And I'm going to go like this. Aluminum's a metal, right? But every other element on the stair step is what we call it. We'll do green. So boron, let's see, what is this one? Silicon, right? Germanium. Anyways, all these elements that are here. You notice top and bottom, except for aluminum. Aluminum screws the pattern up. These are all known as semi-metals. Now, let's do that. Now, if you're to the left of the semi-metal line, is what we refer to. And the line includes these boxes, okay? So if you're to the left of that semi-metal line, or below it for that matter, so that's going to be, let's see, peach. That's all of this stuff. And then I don't really know what to do with these other ones. In fact, these bottom ones I really don't know what to do with either. But I'm going to go ahead and color them anyways. Okay. These are metals. Oh, I thought it was peach, but it's more like a gold color. Yeah, so those are all the metals. Most of the periodic table is made up of metals. And then on the right of that, okay, these are the nonmetals. Use a dark blue here. For sure down in here. Now, the other nonmetal is this guy, and I got kind of carried away because that's hydrogen, right? So that's another nonmetal. So these colors, this dark blue, this is nonmetals. And they get grouped into these classifications because of their properties. Okay, so we'll talk a little bit about the properties of metals, and then we'll talk about a little bit about what nonmetals are like, but really nonmetals are just not like metals at all in any of their properties. And then semi-metals, some are somewhere in between. They have some of the properties of metals, but some of their properties don't look like the properties of metals and are more like the nonmetals. Okay, so you don't need to know all the details about which elements are which and what their properties are exactly, but in general, these are the kinds of things that you'll need to know. Okay, so metals, lower left side of the periodic table, and the middle, so all those transition elements, those are all metals. They're good conductors of heat, right? So that's why we don't usually like roast a marshmallow with a metal fork. We usually stick it on a piece of wood, right? Because metals are really good conductors of heat, and when you hold it to the fire, the fork gets really hot. The other thing is they can be pounded into very flat, thin sheets, and we call that malleability. And malleability really is the ability to be formed into like a foil. okay? They're ductiles, which just means, or ductile. I say ductile because it reminds me of an old joke about ducks and their tiles. But anyways, ductile because they can be drawn into a wire. So it can be pulled and extruded and made into these very thin wires. They're shiny when they're pure, right? And oftentimes you'll see a metal like aluminum, and aluminum doesn't look that shiny because when you're actually looking at aluminum, you're looking at aluminum oxide, which is not shiny. Okay, it's a compound. But pure aluminum, like when you scratch it, you'll see a shiny a surface for a brief moment, and then it'll get cloudy because it reacts with oxygen in the air. So they often, when they undergo chemical reactions, right, they will lose electrons. So what that means is this term here means they form cations. And then all of them are solids except for mercury, and mercury, Hg, right, is a liquid. So like we'll look at some of this on the periodic table here, right? So this is where mercury is here. That's a liquid. And then you can see all of these light green and then everything to the left, those are all metals. All of these ones are man-made and sort of speculative elements still, right? And then all of these ones are also man-made. There's no stable isotope. So if you see this number that's down here like this, I won't spend a lot of time on this now, but we'll talk about it much more later in the year. Those are the masses of the most stable elements. So all of these elements are essentially naturally occurring except for the ones that have parentheses around them. So you'll see there's actually quite a bit of man-made ones, actually. Yeah, so those are all the metals to the left of the stair step. All these green ones, acetane, very little of that actually exists. It only exists as a result of other elements decomposing. Through nuclear reactions, not chemical reactions, but through nuclear reactions. Very small amounts of that exist. So it kind of appears that it's a semi-metal, but it also has some other weird properties. So I don't usually just color it in, I just kind of leave it blank. And iodine is definitely a non-metal. So that kind of follows the pattern that I drew for you on this chart that is here. Like that, okay? So I don't know what to do with that one. Acetane, there's so little of it. I just leave it blank and just say whatever, because I'm not going to test you on that for sure. Okay, but the stair step, right, you kind of got to know where that stair step is so you know where the metals and the nonmetals are. Okay, so these are the properties of the metals. What are the properties of metals? Nonmetals, they're all different. They're poor conductors of heat electricity. They can't be pounded. They're not malleable, so they're not like moldable. They're often brittle, in fact, for nonmetals. They're not usually shiny, and they tend to gain, nonmetals tend to gain electrons. So if you think about the properties of metals, right, nonmetals gain electrons. Oh, I don't know what happened there. And so if you think about properties of metals and nonmetals, they're basically the opposite, okay? Many of the nonmetals are gases, although there's a lot of them that are solids, okay? So let's talk about that just real quickly here. The noble gases are all gases. Hydrogen is an elemental form. That's another one of the nonmetals. That's usually gas, as H2, okay? And then the rest of them are solids except for bromine. Bromine's actually a liquid. That's why it's blue, right? Mercury is blue on this periodic table, and the bromine's also blue for that same reason. It's a liquid. Okay. Next. Let's see, where are we at here? Oh, yeah, so I talked about transition metals. These are the inner transition. And if you were to place them in the periodic table, they go right here. And why do you think they're called the inner transition metals? Because they're inside the transition metals. And most of the time when you see a periodic table, it looks like this, simply because if you add the inner transition metals in, it makes it super wide and you can't put it on one sheet of paper and have it be readable. So really, that's kind of the reason for the inner transition metals not being in the periodic table, okay, just formatting. Okay. So nonmetals, again, upper right-hand side of the periodic table, there's a total of 17. 5 are solids at room temperature. 1 is a liquid at room temperature, and 11 are gases. So there's a lot of gaseous nonmetals: hydrogen, helium, nitrogen, oxygen, fluorine, and then there's neon, chlorine, argon, krypton, xenon, and radon. So a lot of the nonmetals are gases. Of the nonmetals, right, there are some that are molecular, and I mentioned this in the last lecture, chapter 1 lecture actually. There are a lot of diatomics. Okay, so all the halogens are diatomic. Hydrogen is diatomic. And if you look at it on the periodic table, the other ones that are diatomic are nitrogen, oxygen, right? Fluorine, chlorine, bromine, iodine. Oh, sorry, and bromine. Let's see. Yeah, iodine, like this. And you might include the one down here, but there's really not much known about it. And then, well, there's probably diatomic is my guess. Then hydrogen. These are the diatomics. Now, this is off on it by itself, but the rest of them make up a 7, and then if you count them, there's 1, 2, 3, 4, 5, 6, 7. And when we say diatomic, actually, in their elemental form, they come like this. So if in a question it says hydrogen gas or nitrogen gas or fluorine gets produced, okay, it's never fluorine by itself. It's always diatomic, okay, unless it says atomic fluorine, and then it's atoms of fluorine they can produce. The other molecular elements are phosphorus and sulfur. Those are P4 and S8. All right. Next, what we'll do is talk about ions in the periodic table.